Okay, hope you can hear me. Good morning, everyone. Welcome to this talk in which we'll talk about security, Kubernetes, and eBPF. My name is Neependra, and we have Abdul. I'll just do a quick intro in a minute. Let's just look at what we're going to cover in this session. First, we look at what is security observability in general. What changes with K8s? So as we have been having those tools which have been there for a long time for observability, but with Kubernetes, what is getting changed? That's something we'll look at. Then we'll look at what is the cloud native approach of observability, and then we'll see how does eBPF come to the picture, and then what tools we can use for the observability with eBPF. And then we'll do a few demos to kind of cover that. Quick intro about myself. My name is Neependra. I am founder of Cloud Yuga. We train people on containers, Kubernetes there. Close to 2 decades of experience. I published a book on Docker 2015 and then authored the official first Kubernetes intro course for the CNCF 2017. I'm also a CNCF ambassador and organizer of the KCD Bangalore. Yeah, Abdul.
Yeah, hi. My name is Abdul Karim. I'm co-founder of Lambda, and I've been in DevOps space for a decade. I've authored no books. I've organized no conferences, and none of the other stuff that Neependra has. So yeah.
Doesn't matter, man. Okay, good. So what is security observability? It's a general term, right? As you, if you kind of look at, it's a way to look at your current security risk and how do you track them, and then eventually, if you have tracked them, how do you improve and how do you make things better? That is what is security observability in general. So now, if I talk in terms of Kubernetes, right? What are things you may want to kind of capture, right? Like how many pods are in the privileged mode? If a pod in the privileged mode, it can access a lot of other things like a host system and so on. So we have to be careful that. How many pods or which pods have accessed your sensitive files like etc password files and so on? How would you find them out? How many pods are running in the privileged mode overall? And then if a pod has tried to access some website which is blacklisted. So you have to find kind of all of these answers as you kind of do the security observability for Kubernetes ecosystem here.
All right. So when you talk about a Kubernetes-based system, right, there are multiple attack vectors that are involved, right? There are multiple services where an attacker could try to get into your system and access data or sensitive information, right? So starting from your nodes, your worker nodes, your control plane nodes, your container images, the workloads that are running on your worker nodes. So a quick question, like out of these, which one would you think would be the most vulnerable to an external attack, and why?
Yeah, a question to you guys. Which one? 1, 2, 3, 4. How is it? 1, API server
Cube
endpoint.
API server? How many think that it's Cube API server? Okay, only one. How many think it's Cube proxy endpoint? How many think it's container images? Okay. And how many think it's public facing pods? Nice, not bad. And how many think it's K8s nodes? Chalo, theek hai, like second, third, fourth, and fifth. Fine. The correct answer to this is really small. It's a 2-word answer, and the correct answer is, arey yaar, wo nahi. Correct answer is, it depends.
Sorry.
ठीक है. Joke ही खराब हो गया. Okay. But still, if I had to choose one of these, I would go with public facing pods. Why? 2 reasons. One, because it's public facing, right? An attacker, an external attacker would love something which is public facing. And second, this component is dynamic, right? This is constantly changing within your organization, and your developers would be writing code, shipping features, you know, pushing patches and whatnot. This keeps on changing, and it's really hard to continuously write software which is secure, and it's also really hard to trust your developers. So public facing pods.
Well, it depends.
Cool. Coming to monitoring tools have been around since a long time, since as long as software has existed, right? But there are some challenges with these tools when it comes to distributed systems, right? So the very first challenge is configuration. If you talk about tools, there is New Relic, there is Datadog, there is Prometheus, there is ELK, for your application layer stuff. Then there are tools like TCP dump and Wireshark, which can also give you very detailed network level information, right? But you have to keep configuring these, and every tool has its own configuration challenges, right? Second issue with these tools is resource overhead. All of these agents, they consume CPU, they consume memory, and they essentially cost you money in the long run. And the third problem, the most important problem, is context, right? So let's say if you have a TCP dump, during an incident, you have a TCP dump of a file during an incident that happened, and at a later point in time, let's say a few hours later or a few weeks later or a few days later, you do some RCA around that. A lot of data from that dump is going to be irrelevant, right? Especially the data around IP addresses, right? Source destination. That pod might no longer exist. That VM might no longer exist, right? Auto-scaling groups. And also, you might find it really difficult to map it to which pod this IP actually belongs, right? So that kind of meta usually is not available in typical tools. And eBPF kind of helps you solve all three of these problems. I guess Neependra would be talking about that.
Correct. Yeah, so now if you have to kind of observe the security systems or any general in the cloud native world, right, there are few approaches what you have to kind of take into account. First of all, we should get the real world data. So whenever real-time data, so whenever we are doing observability, we should get the real-time data. And that cannot be later, as Abdul mentioned, right? It should happen directly with a low overhead, correct? And we should also get the context of the pods, of the namespace and so on. So if you just get a tool which can tell you, okay, there is some network traffic going between A to B, but if you can't attach to that given pod and a given namespace on a Kubernetes cluster, it would not make any sense. So we need a way by which we can do that. And now the challenge is also it has to happen with the real time, and it has to happen with a low overhead. Now the best possible way of doing that is with the help of eBPF. How many of you heard about this term eBPF? Okay, so there are a good amount of folks who have learned about eBPF. Now this technology is there to basically extend the capability of the kernel on the fly. So if you have written some kind of device drivers of Linux kernel, or if you have tried to submit some patches on kernel, you know that it takes months or even years to get your software or your module to be part of the Linux kernel. But if there is a way by which we can extend the kernel on the fly with our own requirement. So for example, think about whenever the packet is coming to my network packet or network card, I would like to encrypt it or decrypt it, something like that, right? Whenever the packet is communicating between two services or two applications, right? I want to kind of put some kind of stuff which can give me number of arguments, what arguments I had in that function and so on. So if I can do that, it can become very powerful. And that is what eBPF can allow us to do that. So it is like that what JavaScript has done to the HTML, the eBPF is doing for the Linux. So you can do lot of magics on top of the Linux kernel there. So this is how does the eBPF works. I'll not go too much in detail, but the idea is that it can connect to any functions of the Linux kernel which you may have, any of your programs and so on. So what we have here is we have these top level tools. With those top level tools, I can write my functionality what I want. Like I want to basically, let's say, put a trace at every write call, correct? So I would do that at a high level language, you can say, and that eventually go and modify my kernel. So whenever a write is happening, I can get all the data along with it. Like what are the function arguments to it, right? How much time it took it to come out or go in a function and come out of function. So I can know exactly this much time was invested in a given function. So all of these things are possible with eBPF, and again that is happening on the fly for you, right? So now what that brings us is that we can use eBPF in different contexts, right? Be it network. So I assume all of you have used Kubernetes, and in that you have used kubeproxy. Now kubeproxy uses IP tables method of doing the mapping of your traffic between service to pods. And That is expensive if I look at if I can directly patch with the Linux kernel itself. Because IP tables is a user space based utility, and that takes a lot of time to look at the table and so on. But if I use eBPF thing, it reduces the lot of time to get my traffic in and out of my containers or the pods there. Security, which I'm going to explain, we're going to explain kind of further today, how we can secure much better with eBPF. So as I told you, if I can find out or if I can put a function somewhere or kind of as a marker, whenever write is happening, I know something. I can get a notified of that, right? Now I can say, whenever write is happening on this file, let me know, correct? So think about if anybody is searching your etc password file, you get notified about it, correct? That's a power, right? That's a power which you can get with eBPF. Observability again, when you're going to look at with all of the applications, when the traffic going in and out, you can observe the overall things in a much more simpler way. So we'll look at some of these demos today. And I talked about on the right hand side already that where all you can do that. So literally everywhere in the Linux kernel you can put your probes and get the things done. Now, if I talk about 4 golden signals in terms of the observability, what you will be doing is, if I can observe my processes, if I can observe my network traffic, if I can observe my file access, or if I can observe my layer 7 identity of the network, which means I am completely done in a way of security observability there, right? So all of these things are possible with the help of eBPF, what we just discussed here. So now we look at some of the real world use cases, real world attacks cases with Abdul. Yeah.
Yeah. So as the slide says, right? Let's consider a scenario where you have a multi-tier web application. There's a front end which is exposed to the internet. There are a couple of backend services. There is auth service, there is queuing service, and there is a database, right? All these 4 types of pods are running inside a Kubernetes cluster. Okay. Now assume your front end application has a vulnerability. We already discussed, right? So developers write front-end code and they use a library, or let's say you are using log4j, a very popular logging tool, and a couple of years ago there was this RCE which was there in log4j, right? Or any other library that is being used in your front end, and it gives access to your external bad actor to basically run code inside your pod. In Kubernetes, every pod is associated with a service account, and there is a token which is mounted in every pod. Using that token, a pod can talk to Kube API server and basically get information that is required for it to run. So now the attacker would get the token, talk to Kube API, get details about the Redis database, and essentially via front end fetch all the data that is required. So this is one of the scenarios. Now in an ideal world, front end should not have been, it should not be able to talk to Redis directly. There should be some network policy in place, for example. But by default, Kubernetes does not do it for you. By default, this is how it is, right? Every pod can talk to every pod. Another thing that could happen is the attacker could try to access other components of your Kubernetes cluster, for example, etcd. And if you are not using a managed Kubernetes, if let's say you are self-hosting, and if you have not encrypted etcd, and if you don't have any auth around etcd, and if your etcd is compromised, your entire cluster is compromised, right? They don't even have to go via Kube API server. They can do whatever they want, create resources, read resources, delete resources, or even maybe corrupt data inside your etcd, rendering your entire cluster useless. You could be a victim to a ransomware attack, right? That's another possibility. One more thing to know about containers is containers are not virtual machines. They are not strongly isolated from the underlying VM, right? They are just processes which are running inside some restrictions laid by the kernel, right? And there are exploits and vulnerabilities in the Linux kernel itself, in Kubernetes, that sometimes allow you to break out of the container, right? It's known as container escape, right? So when you escape from the container, you essentially land inside the underlying host or the VM, right? And you can access everything and anything that is running on the host, right? You can access sensitive files, you can modify sensitive files, you can add your public key to authorized hosts, you can run some malicious code on the machine, you can run backdoors. Typically a smart attacker would try to fit in a backdoor somewhere inside the system, either in your data plane or if possible, or preferably in your control plane, so that even if you fix this vulnerability in the front end, they still have access to your systems, right? So I guess these are some of the attack scenarios, and
Yeah,
let's see how to mitigate them.
Correct, that's good. Yeah, so now we have a tool called Tetragon here. This is an open source tool which can use for security observability as well as the runtime enforcement there. So for example, if you figured out that there is a file was opened by this given program, what next? You can quickly kill that program if you want to, right? So it can observe. So what is happening here? It can look at all the data which is coming by eBPF and gives you in a way which you can digest easily and put some kind of the security or the runtime enforcement on top of it. So what we do is once we install Tetragon, we get to write some of the policy like this. As you can see, again, I'll not go too much in detail, but what we are saying here is I'm putting a policy in my system, and if I see that you are accessing my shadow file, etc shadow file, what I'll do next, I'll just kill you, correct? Because I don't want you to allow you to access a particular file. So there are two parts to it. Of course, you can skip that enforcement part. You can just observe, and then you can add observe plus enforcement. So both options are available for you, by which you can do the observability as well as the enforcement there. So here is an example which we'll do a demo as well. So this is what we'll be kind of seeing. So we have a cluster configured and we will be deploying some pods. And if that particular pod, which is a privileged pod, if it tries to access, we can get a count, right? It's like visualizing the things, right? So if you have a dashboard where you can see that which particular file or which particular file is accessed by which particular pod, you know exactly who is the malicious person here, and you can actually go and kill that particular pod. So let's look at demo of it, so that way it would make much more sense. So I have already configured the cluster here. Just give us a minute. Yeah, I think. Okay, because of this configuration, I just need to you have to give me. Okay, wow. Okay, that's okay. So we have what we have is we have a Kubernetes cluster here, which is already configured with a single node cluster. What we have, and it is already installed the Tetragon, the tool what we have. You can always, so you can take this down to URL. You can do the hands-on lab later. But I'll quickly run through it, some of the demos that things are much more clear. So let me just try to, oops. Not expecting this to happen. Okay. Now, just give me a minute. I should be able to do that. Oops. Yeah. So what I'm doing right now is I'm just going to run this particular command of Tetragon, which is going to help us get the kernel details. So you can see here I have installed Tetragon, and I am now trying to look at the messages from the kernel which is coming by eBPF, which we are simply putting down in a much more readable format here, because if you look at the raw data, it's going to be much more complicated, but because of the Tetragon command we can see it in a much more digestible way here. Now what I'll be doing is I'll be creating a kind of a pod here, and that pod is going to help me see that sensitive file. So let me just do that. So yeah, this is the pod. So I'll just deploy this. This is a policy, sorry, this is a policy which I have done. And I'm going to deploy the pod as well. So this pod is a pod which is a privileged pod. And in this privileged pod, I'm going to run the commands to access the file, that privileged, the password file what I had. So let me just do that. Yeah. So what I'll do is I'm going to exec Yeah, so I'm now in this particular pod, and I'll do ns enter here. Now what I'll be doing is I'm going to access the etc password file, and you can see here in the messages at the bottom, we'll see that some of those things are going to come. So as I access the etc password file, it has been accessed, and on the right hand side we can see here, at you can see bottom, you can see it is accessed by the dev pod with the cat command, the given file, correct? So now I can get this kind of data in my output of the Tetragon UI or the CLI. I can take this data and then put it on the graph as well, right? So we look at one more use cases of that. The next is if I want to find out some of the executable which are unexpected by the containers to run. For example, ns enter, for example, running the netcat command, running the su command, right? So if I can get hold of, right, which particular pod is running what kind of sensitive commands, that's going to be helpful for me. So I can get this data, and of course on top of it I can put alerts, right? So whenever I see that somebody has tried to run the su command or ns enter command within my container, I come to know about it, right? So all of these things are possible with the help of the ns enter, the tetragon command here. So let me go back. I want to give you another demo in which we'll see that kill one. So I'll just, oops. Sometimes this live demo becomes a bit challenging. Okay, so maybe I think for the interest of time what I'll do is I'm going to skip that. I'm going to show you few more things, but I'll jump into the slide deck here. So now what we have done here is, we can also observe the privilege escalation. So whenever a pod or container try to become the root user, right, I can even observe that. So now what we have done is a demo part here, which I think would be much more interesting to you. And the steps are already given, is there on which you can try it out. So what we are doing here is we have our cluster, our user performs some operations, and we discussed already that we have the Tetragon installed on the cluster. So it would be installed as an agent on every machine. So on all of your nodes, the agent would be installed. And then all of that data, what we are doing is with the help of vector, which is going to help us pass the data in the right format as you wish. And then we are going to put into a parsable. So parsable is an open source solution for the logging. So, and then once we have the data in the parsable, we are using the Grafana, Grafana to look at that log data and give us the big picture about it, right? And then of course I can put alerts and all those things on top of it. So any questions on this particular diagram? Makes sense? Pretty straightforward. You get all of your activities, what you're doing on the cluster, those get logged into the Tetragon or by eBPF on every machine. We get the data, put into a vector so that I can format it in a way, put into a log server which can be other than parsable as well, and then do the graphing as well, right? So let me show you the graph of it right now. So this is how you can see that the graph looks like, and we accessed some of these files right now, that etc password file some time back. I'll just refresh it. I'll just make the time maybe 15 minutes. And you can see here it is showing us that there is this file etc password was accessed via this particular given pod, correct? And now if I see this executable ns enter command was executed by again our dev pod, and that is being shown here, correct? Now if I'll just show you, I'll just because I did this particular lab in the morning, so I'll just go last 6 hours. You can see that it's kind of going to give me all of this data over the time, and and we can see that there are different files we can capture, different commands. I think the graph is still updating. So you can see here who has accessed, who has run the sudo command, nc command, and everything else as well, right? And then you can see here, like at the bottom here, how many, in which pods I have tried to run the su command. I try to privilege, I want to become a root user, correct? So now all of these things are being done by the open source solutions so far right now. There's nothing proprietary here. You can all go and try it out. Parsable, Grafana, eBPF, Linux kernel, Kubernetes is all there, and you can kind of take a look and try it out, right? So I'll just give the link of the lab later. But yeah, go ahead. We'll have one more demo.
Yeah. Right. Yeah. By the way, we do have some time, so if you have any questions, probably we can take
Yeah, please go ahead.
Yeah.
Why can't we use Loki instead of Bot for that? I mean, that is also integrated with
It's a choice, right? It's a choice. You can use Loki.
for vector. I mean, people are using open, so they don't have it at all.
Vector is open source, I believe, right? You can use, I think, FluentDB can use it here, I think, as a replacement of that. Yeah. Yeah. Yeah.
Choose your own poison, man.
Yeah. Correct. Okay, good point. So yes, the question which came along this, that can eBPF can crash kernel? Very good point. I did not go in that detail, but I can go right now. So if I look at this particular here, what happens is when you put your code via the eBPF library inside the kernel, right? There is a verifier. And this verifier guarantees that whatever the code you are putting inside the Linux kernel via the eBPF tooling, it is not going to harm any kernel. That is guaranteed that it will not do it. Yeah. Other questions? Yeah, go ahead with your demo. Maybe we'll take other questions later.
Where's the demo?
Yeah, here.
First one.
It's difficult to know. Your demo would be third one, yeah.
This one?
This one, yeah, correct, yeah.
No, but where are the slides?
Slides. Look, slide on the second Canva.
Yeah.
Made us confused.
Okay, cool. We'll quickly wrap up with this final demo. So in this demo, what we are going to see is following up with the early examples that we discussed about the real world scenarios, right? So we have a front-end app, we have a back-end application, and we have a database application, right? All three are Nginx in our case. And we'll just see how we can use eBPF. We are using Cilium here, right? So how we can basically restrict access from front-end port to the database directly, right? If it has to access database, it should go via backend and not make a direct connection. And we'll also see how we can basically use Grafana to plot some graphs around, access between these pods. Okay.
You have to see. That's the whole challenge. Yeah.
I'll manage it.
Okay, sure.
Okay. Cool. So we have three pods running here. There is backend, there is DB, and there is front end, right? So let's just exec. Okay. If I just work curl DB here, I should get a response. And if I do the same thing from my front end pod, wow, it is difficult, man.
Spelling exec. Come on.
Okay. So if I do a curl DB from here, it is going to timeout. Why is that happening? We'll also quickly see that. I do. All right. So this is a Cilium network policy that I'm using. And in that, if you see, I describe the endpoint first, the endpoint that I want to protect. In our case, it's going to match based on the label. So if the application is DB, right, it's going to apply this policy for all the services that are running with AppDB, and it is only going to allow applications that have these two labels, right, backend, app backend, and environment prod, right. So in our case, the front end is running with app front end, although it is in prod environment. It won't be able to access the database pod, right. So this is the policy. Again, we had to make no changes in our application, nothing in our ingress. This just runs, as a native Kubernetes object. And only with this, we also get a bunch of observability around this. So if you see last 15 minutes, is this text visible? Okay. So if you see, I have some traffic which is running from my backend to my database, right? The green part of the graph. I'm sorry for this resolution thing. Can I minimize or something? I don't know.
No, I
Cool. So this is normal traffic, and in the drop section.
Yeah, too.
What the hell? Okay. So we just made a few calls from our front end as well to the database. I mean, we tried to make a call, it did not go through, but that is also captured here. So in case if somebody is trying to do something wrong or something that you have not configured your cluster to allow, you can easily create some dashboards around this. There are also some other L7 metrics that you get out of the box when you use Cilium and eBPF based solutions. So these are kind of the community dashboards from available from Hubble via Hubble. So do check it out. And I guess that's the demo. That's it.
Yeah. So I'll just list down. So this is the URL of the app, the lab. If you want to kind of try it out on your own, it is not in the final stage, but in a couple of days we'll just fine tune it, and then you should be able to perform all the steps what we have done, and you can try out whatever we have said so far. With that, we can build observability of the Kubernetes cluster end to end with the help of all the open source tools. And what you can do extend is you can put alerts on top of the parsable, and that can give you alerts on your Slack or wherever you would wish, where somebody, if some unauthorized file has been accessed or whatever we discussed, right, has been done. Yeah. Thank you.